Okay, here we are. So, now when I walked around, obviously I was not checking to see if you did these right or not. I was simply going around to see if you attempted them or didn't. Now, of course, we will talk about whether or not you did them right. So, if you did them correctly, then your graph will look similar to the graphs we produce right now. If you did them poorly, then what should you do when we put the right ones up here, Jack? You should fix them. Some of you won't, and then you will complain when you get bad marks on your tests, and I will say, to which you will say, and then I'll see you next year. What are the two things that I am counting in number 5? Height and time. One of those is an independent variable. One of those is a dependent variable. Which one is independent? Time. So time will be down here. Height will be over here. If you have done that, you are halfway to getting this correct. Now, the next thing. On the far left of this graph is 0 time. What is the height of the swing at 0 time? No, because then the swing would be sitting on the ground, and it would be very hard for you to swing. So it needs to be a little off the ground, doesn't it? So that's the first point. It cannot be at 0, or swinging would be difficult. Allow me to illustrate. Ground, swing bottom, my bottom, somebody give me an underdog. Somebody's going to come give me an underdog?
Where you run under the...
How can you not know what an underduck is? You push the guy and you run under him.
I've never done that before, but I want to now.
Oh, good God.
What is wrong with you?
I know,
I
right?
don't know.
Grew up in an igloo.
Doctors don't know either.
All right, so you can't start down at 0. So that's the first thing you need to fix. If your graph starts in the bottom corner, is no good. Okay? Next thing. When you start to swing, how does it start? Very slowly. Do you go very far off the ground that first swing? No. So you're going to go up very little in a certain amount of time. Then you're going to lift your feet up, yeah?
Yeah.
And what's going to happen to the height of the swing? No. I am going to lift my feet up. The swing is now up in the air. And then I'm going to lift my feet up. What happens to the swing? It goes down. How low?
Not to the ground.
Not to the ground, or it will hurt. You will go thud and break your tailbone. But we remember that the tailbone has a proper name, the coccyx, which is always fun. He broke his coccyx. Now, it is going to go down to the original height, right? And then if you are an efficient swinger, you are pumping your legs, and the next swing will go where? Slightly higher. What will it never go lower than? The original. Eventually, it will top out, and you will continue at that level. If you don't have curves, that's okay. All right? Now, also, does the speed change? Yeah, but your distance between heights also changes, right? So, as long as you have something like this, you have done it correctly. What I'm looking to avoid is the people that drew it this way. Because that's the way a swing goes. Because, of course, what's wrong with that? That means time's going backwards and you are swinging faster than the speed of light.
Wow.
Yes. That is one heck of an underduck. Okay? The other thing that will never happen is you will never loop around the bar, no matter what your grade 6 brother said to you when you were in kindergarten. I once knew a guy that swung so far, he got all the way around the bar. It's not true. It can't happen. No. Even with rocket boosters, it didn't work. On Mythbusters, they still could not make it happen. All right. So, everybody cool? Brianna. So your graph just keeps going up?
Yeah.
Well, at some point, according to that graph, you never went downwards. So you just kept swinging higher and higher and higher and higher, which is, of course, impossible. Any questions about the first one? Going once, going twice, going thrice. Okay. Next. What is the key word in the question for number 6? Distance. Is distance a scalar or a vector? Scalar, which means does it have a direction? Other way around. Right? So, what goes on the bottom? Time. What goes on the side? Distance. And when you have 0 time, before you click the stopwatch, have you traveled any distance? No. So you start at the bottom corner, 0, 0. After you run for a certain amount of time, how far have you run? How far have you run? Because it is a different tense that I am using. How far have you run after a certain amount of time?
Depends on how fast.
Guys, it's a 400-meter race. How far have you run at the end of whatever amount of time? 400 meters. So up here you need 400. Does time matter? No, because no matter how long it takes, you only went 400 meters. Now, if you ran at a constant speed, what will the line look like? Straight. Shroomp. If you ran a little ways and then got out of breath because you're lazy and took a break, what will happen to the line? It will go up and flat, up and flat. What if you were running it like a race? How would you start? Slow. So you're covering how much distance in the amount of time? If you're going slowly, how much distance do you cover in your time? A very little amount. So you start out covering not much distance in a lot of time, right? But halfway through, you notice that you're not going to win. So what do? You speed up a little to cover more distance in less time. What do you do at the very, very end? Speed boost. You hit that X on the buttons. The nitro, whatever video game that you're used to playing, because you don't actually run anymore. You play video games and make avatars run for you. Then it's going to go up very steep at the very end for a quick finish if you're running it like a race. Do I care what your line looks like? No. The only thing important here is because it is distance, the line can only go where? Up. Okay. What if you run halfway around the track, realize that you forgot your wallet, and run all the way back, and then finish the race? It's still distance, so the arrow would still go up past 400. It would actually go up to 800, wouldn't it? Because you ran 200, 200, 200, and then 2 more 100. Right? Okay. So as long as you have it going up only because it is distance, you have done it correctly. What is different with number 7? It says displacement, which is what? A vector, right? It's got a direction and a distance. So now I've got displacement over here and time. Now this depends on the kind of track you say you are running on. Yes? If it is a straight line track, a quarter-mile track, and you are over in Mission, and instead of driving the car, you run the quarter mile, then what would the line look like? If you are running a 400-meter race on a 400-meter track that is a straight track, it would be the exact same as number 6, right? But though that is not the track of which I speak. Do not lawyer ball. What does a track look like for running on? Josh. It is an oval. Right? And essentially, each side is 100, and each corner curve is 100. Yes? Right? Essentially, this is a straight line. Yes? Because when you watch Usain Bolt, he runs in a straight line. Yes? It's 100 meters down the side of the track. Now, really what it looks like is this. It's straight for most of it, and then the track curves away, but the 100 meter goes here. Right? But let's not get crazy. Okay? Where I start matters, yes? If I start right here, for example, and I start running, I'll get it.
I believe in you.
Go for Myers.
I'm not here.
I can. Okay. That's an interesting person to be sent to the principal. Mr. Weens. Mr. Sadu would like to see you. It means they can start speaking. Go for Myers. I'm the person that is on the phone. Okay. If you are not looking for Myers, you should not be speaking when I say go for Myers. So when people dial the wrong number, which they do all the time because apparently nobody can read the timetable, it's going to be very fun next semester when I have a prep. I will get calls daily for the wrong teacher. Because I am not in the room for one of the blocks next year and the blocks rotate. Already I get calls for the wrong student. Can you send Joe down? Joe's not in my class till next block. Oh, sorry. Click. Because, timetables are very complicated. No. Why would I call Mr. Shippets? I talk to Mr. Shippets when I need to talk to him. He's just down the hall. What are you trying to say? It's not like I got to talk to Mr. Cicchetti in the gym. That I would phone. But to talk to Shippets, I would walk down the hall. Huh? I know you guys text your parents from the basement, and they allow you to do that. I, of course, do not. I also do not allow that either. All right. Where was I? Oh, yes. If I start here... Yes, Brianna? Do I allow my kids to play video games? Of course I do. Do I police my kids playing video games? Yes, because that's the way the world works. I am allowed to drink beer. If I drink too much beer, I do stupid things. Part of growing up is learning when to stop. So, as long as video games do not get in the way of what my son has to do, he is allowed to play video games. Unfortunately for him, video games are always in the way of what he has to do. Therefore, he does not get to play a lot of video games. But if he could understand that responsibilities come first, not the other way around, then he could play all the video games he wanted. But he cannot understand that, much like most of you. Why did you not do your homework? I was playing Call of Duty until 4 a.m. Okay. I do hope you find a job playing Call of Duty until 4 a.m. And I hope if you do not find that job playing Call of Duty till 4 a.m., because it does not exist, I hope you find a job where they will let you not do your work because you played Call of Duty till 4 a.m. Oh, wait, that job doesn't exist either. Oh, silly. Huh? Yes, there are plenty of jobs existing testing video games. Right? Right now in this building, there are 1,100 students. Would every one of you like a job testing video games? Yes, you would. Do you think there are that many jobs? A, do you think there are that many jobs? No, of course not. There are not that many jobs testing video games. 2, how many video games do you think are invented daily that suck and never get made? Millions. You have to test all of them. Of course you wouldn't. because it would suck. Because the real thing to remember is that no matter what you choose to do with your life,
It always sucks.
it is called work for a reason. And there is an opposite of work, which is play, which is what everybody would rather be doing. I love my job more than anything. I've wanted to do nothing but be a teacher since 1989. If somebody said to me, we're not going to pay you anymore, do you think I would stay here?
No.
Even though I love this?
Yes.
No, I would not. Now, if they were to say we will give you food, shelter, a car, and pay for your entertainment, but you would get no spending money, would I stay here?
Yes.
Yes, because I would have everything I would need.
Oh yeah, you would get food.
Now, back to where we were. If I start from here and I leave, I start running. Here I am. I'm running.
Wow, that's a good drawing.
As I leave here, am I very far from where I started? If we assume that the curves are 100 meters, when I get to here, I have traveled 50 meters, haven't I? But am I 50 meters from where I started? No, because of course you would measure this distance, shortest distance, yes? Everyone understand? So in that first little bit of time, assume it takes me a minute to run 400 meters. I have run 1/8 of that, yes? Because I've run half a quarter, right? Everyone agree? So in that first eighth of amount of time, I am not going to go very far away, am I? Because I'm still real close, right? Everyone agree? So in the first bit of time, so let's assume it's going to take, I'll write it in quarters, 1 minute. In that first half of a quarter, right, because this is an eighth of it, I'm going to not go very far away, am I? Right? Now, what happens in this part? Now I'm going double what I just went here, right? So I'm taking twice as long, so I'm going to go all the way out to here. And I'm getting much further away now because I'm going straight away, yes? So I'm going to go up significantly steeper. Agreed? What happens right here? A curve. Am I still going away from home? Yes, but it's going to be a shorter amount, yeah? So I'm going to take this little half and I'm going to be going back at about that same level, yes? What happens right here? I turn this corner and now what happens? I'm going back. And since it's displacement, the line must go down, yes? And would it not be exactly the same, just reversed? So down a little till I hit the straightaway, down steep, and then down shallow. That's to do it perfectly. But again, it depends on the kind of track you drew, right? Mason drew a different track, but did his graph perfectly for his track. Okay? Everybody understand? Now, if we use a running track like we should, then that is what it would look like. The key here, though, is that because it is displacement, we must get back to where we started. Whereas on distance, we wouldn't. Now, what distance is that peak at? 200. Because we went 200 there and 200 home. Does everybody understand the difference between displacement and distance? Yeah? Going once? Twice? Thrice. Do I care if you remember the words scalar and vector? I do not care. But you need to be able to know which is which. Right? What? A scalar has only a magnitude. So it's only got a value. A vector has a value and a direction. So when I drive to Vancouver, Nick, on the highway, I'm going 120 kilometers an hour. Okay? Is that a scalar or a vector? No. That is a scalar because I just gave you an amount, 120 kilometers an hour. Now, when I tell you I am driving 120 kilometers an hour west, what is it? That's a vector. Okay? 120 kilometers an hour is a speed. 120 kilometers an hour west is a velocity because it is a vector, because I'm going in a direction. Okay? Cool? All right. And then, of course, number 8 would change for everyone, yes? Now, I used a different word this time. What? Position time. Is that displacement or distance? Close your eyes. Are they really closed? Open them. Open them. How far did I move?
We don't know. I'm sure.
How far did I move?
Somewhere.
No, I didn't move anywhere. I'm in the same position. So therefore, position time is which? Displacement or distance? Displacement. Right? Because my position has not moved. That's the only thing you could graph. Right? I didn't actually get up. I swiggled my seat around a little so you would thought I get up and took a few steps. These guys gave me away. Thanks, Carlos's.
Wow. Carlos squared over there. He's throwing an animation into the stove.
It's not Carlos squared.
Carlos is.
It's not cubed. No, it's not Carlos times Carlos. It's Carlos plus Carlos. It's 2 Carloses. They're not squared. Carlos squared would be that Carlos in a square. There'd be 4 of just him.
There is.
No, there's not.
What if he has 4 personalities?
That's not really a real
What
thing.
if he's quadpolar?
Those things, the multiple personality disorder was invented for the movies.
What if we actually did math?
Ooh.
Talking about my stuff.
Riley, really? We are talking about math, though. We're talking about the difference between squaring and doubling. So which is this? Displacement. Excellent. So when I draw my route to school, because I'll use mine for an example, if at any point I have to turn back home, what would happen to the graph? It would go down, right? Would it ever go left? No, because my Ford Focus does not go faster than the speed of light. Of course I drive a Ford Focus. I drive a sensible family car due to the fact that I have a family. No, it's not as good as driving a Prius. The Ford Focus sucks compared to a Prius. Huh?
I hate driving a Prius.
Get a Focus RS.
Yeah, right?
What's so good about a Prius? It's good on gas and it's a Toyota product. The best car company in the world, plus it's better on gas. Now the argument to be made there is, are those batteries in all these electric cars really better for the environment than gas? What's going to happen to those batteries when they wear out? They got to be destroyed somehow, and they got to be made. How are those batteries made? From metals that are mined out of the earth. How do we mine stuff? By destroying the environment. All right, so our position is over here, and our time is down here. Now for me, I live in the middle of Chilliwack. So when I leave home, am I driving fast? No. I'm driving 50 kilometers an hour. Now it takes half an hour for me to get to school, and school is 30 kilometers away, right? So I know my position. The maximum position is going to be 30, yes? Because school is 30 kilometers from my house. Yes? Sure.
Do you go on the highway when you go to school?
I do.
Is it too cramped? Is it really busy in the morning?
Weirdly, Tasha, the difference is a couple of minutes. If I leave my house at 7:20, almost a straight shot to school, almost no traffic. If I leave my house at 7:25, horrible traffic. Very weird. If I leave at 6:30 because I want to be here really early, I almost do go light speed. I almost get here before I left.
So how fast do you go on the freeway?
120 kilometers an hour.
Oh,
Speed limit's 110.
what?
You didn't know that?
I know that. What?
My dad was driving to Vancouver one time. He forgot that we had been in the States, so we changed our car.
Oh, yeah, that happens all the
We
time.
went 120 miles.
That happens all the time. It happens all the time. One time I was doing gas, and my gas gauge didn't work on the car, and I was in America, and the sign comes up, next town, 55 away, and I'm thinking 55 kilometers. No problem.
Oh no.
Yeah. I had enough gas to go 55 kilometers. Sadly, 55 miles is 80 kilometers. So yes, there was some walking involved that day. All right, so we're understand that it's 30 and 30, yes? At the beginning, for the first 8 minutes of my drive, I only go about 5 kilometers because I got stoplights and I'm going, all that's in the way, right? So if I go up by 5s, 5, 10, 15, 20, oops, that was bad. Anyway, 5K, and I go up in 5 minutes. So I go in 8 minutes, I go 5K. Now, would this be a straight line in reality? No, because I got stop signs and stuff, right? But for our intents and purposes, I'm going to draw a straight line, right? What happens then, do you think? I hit the highway. And what happens? Does it go up or flat? Up. Because I'm covering a lot of distance in significantly less time. Does everybody understand that? So I come out on the highway right down there by UFV, right? Which is 2 kilometers away from here. So I get up to 28 in very short amount of time, right? I get like that now,
Wow.
right? Now, the last 2 kilometers takes a long time because of traffic and because I'm not on the highway anymore and I'm down to 50 kilometers an hour. Everybody cool? Now, in reality, what should happen on these lines? If I was doing this exactly, every stoplight, what would there be? A little flat line. Everybody cool? Right? If there's a traffic jam on the highway and I stop dead, there's a flat line. Right? Right? Okay. Now, all you guys would have something different for there. If you walked, right, you have a lot of time and very little distance covered, yes? Right? Depending on how you scale the graph. Right? Everybody cool? All right. Good job, everyone. There's no such thing as a suede tie. Turn over to page 155, please. I'm going to do something different with 154 later on. All right. On the page, I have a relation, yes? Because a relation is any time I compare 2 sets of data, yes? So what are the 2 sets of data which I am comparing in this scenario? Nick? I am comparing cost, which I am measuring in money, and I am comparing time, which I am measuring in days. Right? Everyone agree? Okay. Which one of those is the independent variable? Time. So down here is going to be time, and it is going to be measured in days. How many days do I need in order to graph this relation? 7. 1, 2, 3, 4, 5, 6, 7. Is everyone cool? Okay. What is our cost measured in? Dollars. Right? So now I need a scale up here. Let's go up by 50. 50. 100. 150, 200, 250, 300, 350. Is everybody cool? Everyone agrees with how we've set the graph up? Everybody can follow it? Excellent. Okay. What would our first possible input be? What is the smallest amount of time I can rent a car?
1 day.
Am I renting a car right now? So what is the smallest amount I could rent a car? 0, because I did not go out to rent a car, did I? I've sat right here. I'm not the Flash. I did not run to budget and get back here in time to rent a car and still teach you math, did I? No. So if 0 is the lowest possible input, there's a bug. Nope, missed him. Is there an output for that input of 0? No, because I can say, I'm going to go rent a car, but I can't actually rent it for 0 amount of time, can I? If I walk into budget and say, I want a car for no amount of time, is there a charge for that? No. So at 0, I have an open dot, right? Because it doesn't exist. Does everybody understand? Excellent. Now, if I take that car and drive it off the lot, how much am I paying? $65. For how long? 1 day. So up to 1 day. Is 1 day included? So what kind of dot does that get? Solid dot. And how much should I pay for that? 65. Is everybody cool? Okay. Now, if I choose to go longer than 1 day, then I got to pay another $65, yeah? So at 1, up to 1, I'm included in my 65, yes? What if I go a minute over? Then I got to do another 65. So, do I put an open or a closed dot here? Open, because once I hit more than 1 day, I'm paying, right? How long does that line go? Another day out to 2. What kind of dot there? Solid. And how much did I pay? I paid 65 already. 130. Everybody cool? Everybody cool? Okay, what happens on the 3rd day? Open dot, out to 3, and how much did I pay? 195. Is everybody cool to there? Okay, what happens next? I only pay 30. So I still go up. It's still an open dot. Oops, that should be black. It's still an open dot. It goes out to 4. But what is it now? 225. Right? Everyone agree? Everyone agree? Okay. What happens next? 255 to a closed dot. Then 285. Then 315. Is everybody cool with our graph? Now, the next question right there, should the points be connected? Now let's stop a moment because we could connect these in 2 ways, couldn't we? Okay. One way, and I'm going to write a blue line for one way we would connect here, we could do this vertical line here. Does that make sense to connect those points? Why not? That top one doesn't exist, does it? And is there any outputs for anywhere on that line? No, because you can't pay any amount except 65 or 130, yes? So there are no outputs for that blue line. So the blue line we would not use because there's no possible output. Right? Okay. What about if I were to do a green line? I'm going to get rid. The green line would go this way. Should I connect those dots? Would it make sense to connect those dots? According to that line, if I rented the car for half a day, how much would I pay? I would have to pay that much money, yes? Do I? What do I pay? I pay 65. So can I do the green line? No. I can't use the green line. Not usable. I should have said usable. Because we only have inputs and outputs for total, or for, not total, sorry, whole days. Everybody understand? Now, next question. Is this a function? I'm going to erase the blue lines because they aren't needed. I erased a black line there, sorry. Is it a function? Do we have it graphed? So what math tool allows us to check if it's a function? A vertical line, yes? Are we okay?
Yeah.
Are we okay?
Yeah.
Are we okay?
Yeah.
Are we okay?
Yeah.
Why? I'm going through two dots. The top one doesn't exist. So is it a function? Yes. What makes it a function? Yes, there's only one output for any given input. Everybody cool? All right. Now I'm going to ask you guys to do this one because it's tricky. What's the domain? What's the range? When somebody has an idea, they could put their hand up and I would say, you! And you would say, okay, you!
Is it possibly like when we technically go from 0 to 0?
So 0 greater than
Or less than, sorry.
less than or equal to, not x, not y, t for time, because the domain is time here. It's just on the x-axis. Then what?
7.
Less than or equal to 7. This is almost perfect. I would make one change there. What change would I make? Nick? It's not equal to 0, is it? Because I can't rent the car for 0 amount of time. I'm not renting it. Right?
Why do we put brackets in some?
There's no
Like
brackets.
not on these ones, but it's some of these you put brackets on some of them.
Yes, because one of them is a different way of writing it. This is an interval. It covers 7 spots on the x-axis, yes? So that means in this one, we can write it with brackets. Why is that one curvy? Because it doesn't hit 0. 0 is not included. Why is that one square? because it is included. I hit 7. Cool? All right. What's the range? I can't pay 0. 65. Then what? Nope. No. Why can I not put that? Because the next value is not anything between 65 and 130. What is it? 130. What's the next value? 195. What's the next value? 225. Next value. Next value. Next value. 315. Can I do the brackets here? No, because I am not doing an interval of the y-axis. I am only doing 7 points on it. So I can only put the squiggly brackets. Does everybody understand? When I do the domain, which I'm going to use blue highlighter for, because I do my domains in blue, every one of those values is included, isn't it? If I ask you, hey, Brianna, you want to rent the car for 3.5 days. There's 3.5, yes? Is there an output for 3.5? Yes. How much is it? 225. You with me? Okay. You cool? Now, hey, Brianna, how long can you rent this car for if you want to spend $100? You can't. You can only rent it for 1 day. 65 is the only possible output that you could get to, right? So on this scale, I can only be 65. This is supposed to be red. 130, 195, 225, 255, 285, or 315. I can't be anywhere in between. This says I can be any number between 0 and 7. I don't have that option in the range, do I? I can only be those. So I have to list them point by point. Okay? Everybody? Awesome. Now we have 2 new words here. Discrete data and continuous data. You guys are smart kids. In English, what does the word continuous mean? It says so right in it. It continues, Mr. Myers. A duh. Which means if it keeps going, it is unbroken, yes? Do I speak at you continuously?
Yes. No. He's not speaking right now.
Okay. Do most of you continuously not do your homework? Yes, because I have a list to prove that. Everybody understand? Okay. So we know the difference between continuously and discrete, right? So, knowing what you know about English, do you think, and I haven't told you, do you think I have graphed continuous or discrete data here? I got 1 continuous, I got 1 discrete. I got a seconder for discrete. Do I have a third for discrete? 4 for discrete. You've changed your mind. Okay? Why do you think it's discrete? One of you 5 people. Because the other 25 people didn't want to guess. Okay, so you're arguing that it ends at 7 days. So it can't be continuous. All right, I agree. I agree with you because technically we cannot rent the car for an infinite amount of days. But it is not continuous or discrete. It is continuous data or discrete data. Of the data we have, is it continuous or is it discrete? Now I will allow you to change because now that you've tried to lawyer ball me, I have straightened you out a little. Is it now, again, continuous data or discrete data? You still say it's discrete? Why, Sam?
Because the money, you don't pay continuous amount of money. You only pay what you have to pay.
Okay.
If you rent for a day and a half, you still pay 130.
Okay.
You're not paying
Okay. I hear what you're saying. So by your definition, you would not be able to tell me how much it would cost me to rent the car for 2.25 days.
Well, it would cost you $195.
Mm-hmm. So is there an output for an input of 2.25 days? Yes. You with me? Okay. Is there an output for any given input? If I rent the car for 1 day and 1 minute, 24 hours and 1 minute, is there an output? If I rent the car for 6 days, 23 hours, and 59 minutes, is there an output? What if I had 30 seconds to that? Is there still an output? So is there an output for any given input? Is any input possible over the scale of the data from 0 to 7? Can I input any number and get an output? Yes. So I'll ask you again. Is it discrete or is it continuous? It is continuous. Even though the line is broken. Does everybody understand that?
Yeah.
Okay. So what that means is continuous data. There is an output for any given input that is part of the domain. No matter what fraction I put, if the number is between 0 and 7, can you tell me how much I am renting the car for? Therefore, it is continuous. Is everybody with me? Everybody cool? Okay. So what must discrete mean then? So how would we word that?
There is many outputs from one input.
Pardon?
There's only output, like, I don't know.
Every input is not from one output.
You're on the right track. It has to do with inputs and outputs.
There is more than one output for any.
Okay, so I'm going to deal with Riley first. So Riley says there's more than one output for a given input, right? Okay, so I'm trying to think of a way to say this. That would be, and don't write this down, according to Riley, there's my graph, right? My input of 7, and I draw a straight line up from 7. Consider that straight. My input is 7, right? And I have outputs from 3 up to 14, right? Since it's a solid line, is every single fraction there an output? So for that input, you can give me an output all the time, can't you? So is that continuous? Yes. So you're not quite right, but it has to do with input and output. Now let me ask you this. What if I change this to this? Is that discrete or continuous? That's discrete. Why? Because I don't have constant outputs, do I? Or do I? Is there an output for every given input?
Yeah.
So is it continuous? I'm asking you guys to think this through. Is there an output for every given input? Yes. So just wait. I'm going to change this drawing slightly. Okay? That was a vertical line. Now, 3 out to 7. Do I have an output for every input? If I put a dot anywhere from 0 to 7, do I get an output? So is that continuous? No matter what I say. 3.2. 3.2, is there an output? Yes or no? So is it continuous? Okay. What about this? Okay, what if I put closed dots? Is that discrete or continuous? What do you assume I have made these? That's 1, 2, 3, 4, 5, 6, 7, right? Okay. So at an input of 1, did I have an output? What was it? 3, right? I input 1, I output 3, yes? At an input of 2, what was my output? 3. At an input of 3, what was my output? At an input of 3.5, what is my output? There isn't one, is there? There is no dot there. So this would be discrete, because I cannot get an output of any inputs except 1, 2, 3, 4, 5, 6, 7. Do you understand now? Okay, so I'll ask again. What would discrete data be? Not every input. There is not an output for any given input. Now let me give you an example before I make you write anything more. Let's just think about it for a sec. If I buy a 6-pack of Coke at the store, they charge me $2.99 to buy it, and then they charge me for the deposit, right? Right? And when I take those cans back to the recycling depot, they give me 5 cents a can, right? So if I buy a 6-pack, I take all 6 cans back, how much money do I get? 30 cents. So I can take back 1, 2, 3, 4, 5, 6 cans, yes? If I take 1 can, what's my output? 5 cents. If I take 2 cans, what's my output? 10 cents. If I take 3 cans, what's my output? 15 cents. Everyone agree? Can I take back 1.5 cans?
No.
So there's no output for it. So is that discrete or continuous? Discrete. Does everybody understand? Yeah? Okay, let's see how well you understand. Turn the page over to 156. I have 4 scenarios there. For each scenario, you're going to tell me the independent variable and the dependent variable. And then you're going to tell me whether it is discrete or continuous. So look at that first one. Talk to your neighbor if you need to. Do not yell out an answer. Give everyone a chance to think about it. Which of those things there are discrete or independent and dependent? First thing you got to do is decide what are the 2 things that are being counted. What are the variables? Then decide which is dependent, which is independent. I'm going to wait a minute whilst you decide. If you finish the first one, you're welcome to attempt the next 3. But I would recommend talking to your neighbor while I have a sip of coffee. And that'll do. Who would like to tell me which is the IV and which is the DV in the first one? Sam?
IV is the air temperature.
IV is the temperature, and DV is the speed of sound. Why?
Because no matter what the air sounds like, you will probably the same temperature.
Okay, you just said that in a weird way. Yes, okay. Am I speaking right now? I'll give you another chance. Am I speaking right now?
Nope.
Is there a temperature in the air? Okay. So that's why temperature is independent, right? Because no matter what we're measuring, there's still going to be a temperature. Cool? All right. Now, is it discrete or continuous? Why is it continuous? For every input, which is any temperature, as long as there is a sound coming out of my mouth, no matter what we do to the temperature in this room, that sound will continue to come out, yes? Even if we can't measure that small, yes? Right? Because we stop measuring eventually, don't we? Right? I mean, really, we don't measure anything smaller than millimeters in real life, do we? But we are aware that there are distances smaller than a millimeter, yes? Okay, so that is continuous. Because for every possible temperature, there's a sound. Everybody cool? Everybody good? Okay, let's look at the next one. What's our IV? What's our DV? Take a moment. I'm going to spy on you through my ring of masking tape. It's a really big telescope. Ah! It's gone. I got it. Okay. What's my DV? What's my IV? Jack, be nimble.
Your DV is the age, and the IV is the vitamin C.
So Jack says my IV is my dose and my DV is my age, yes? We're happy with that?
No, I'm not happy with that one.
So when you pick up something that has directions on the side, it says, take 1 tablet if you're alive? No. Female's age goes up, needs for vitamins change. So is this right? No, it is the opposite. The independent variable is the age. The dependent variable is the dose. Right? Does everybody understand why? Have any of you ever taken a painkiller and looked on the side of the box? What does it say? For ages 6 to 12, take 1 tablet. For 12 and over, take 2 tablets. Right? Which one of them is independent? The age. Because it's when the age changes, the dosage changes. Same thing here. Is everybody cool? Okay. Now this is tricky. Is it discrete or continuous? That's only there for legality. It means nothing. Is it discrete or continuous? So you say discrete. You started out strong with your reason, and then you... And I couldn't hear you. So please, Brianna, speak as loud and proud as you did when you said discrete, because I...
I don't know, it depends on the person taking it. Like, if they stop taking it, then it's not continuous anymore. Like, I don't know.
Okay, so you could choose to stop taking it.
Yeah, but, like, the dosage doesn't stop. I don't know.
It's continuous.
Okay.
It's something else.
All right. And you say it's continuous. For every given age, okay, there's an output of dosage. So you say it's continuous. All right. Let me ask you this. How old are you? Okay. You turned 15 just now? When did you turn 15? June. This is now November, right? Let's say your birthday was June 29th, right? It's immaterial. Say it was June 29th, yes? And say every month is an equal amount of days. So June, July, August, September, October, November, right? 5 times 30 is 150 days. So you are 15 years and 150 days old, yes? Did you take a pill and cut it into 150 365ths and add that to your dosage? No. So is there an output for every possible input? No, because you are only going up in years. Do you understand, Sam? Excellent. Does everybody get it? Sam makes a really good point because it sounds like it should be continuous. Yes, because for every input there's an output. But is every input available to us? No, because we are only going up in years. Understand? Okay, so let's look at the third one. What are my two? My IV and my DV.
No, because
Cost depends on the juice. If I go into Safeway and I buy no juice, am I paying for juice? No. But if I buy a can of juice, do I pay something for it? Yes. So my IV is cans and my DV is cost, because the cost depends on the amount of juice I purchase. Yes? Now, is it continuous or discrete? Oh, now you said the discrete part slower. You're going to yell your reason now? It is discrete. Oh, I forgot to write the reason up here. What was the reason this guy was discrete? Because we only have whole number inputs. We don't have every possible input. So what about this one? Why is this guy discrete? Because it is discrete. Because we cannot buy half a can we? I'm real thirsty, but I'm not quite thirsty enough to drink a can of juice. So here's $1 Safeway. I'm going to buy this $1 can of juice. Glug, 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 glug. I drank 3/4 of it. Here, I would like 25 cents back. Does that happen? No. So this is discrete because I cannot input fractions of cans when I go to the store, can I? I can only buy whole cans. And finally, number 4, IVDV. Altitude depends on the temperature? Altitude and the temperature is the DV, which is why there is snow and ice on the top of Mount Baker in the middle of August. And there is no snow and ice on the ground here. Almost. Now, here's the next thing though. Is it discrete or continuous? It is continuous. But why, Mr. Myers? We only measure temperatures in degrees. There is a temperature at every altitude, even if it is such a small change that we cannot visibly measure it. Could I move up 1/60th of a meter in altitude? Yes. Would there still be a temperature there? Could I move up 1/9,000,000th of a meter? Yes. Could I move up 1/quintillionth of a meter? Yes. And there would still be a temperature. Because I do not teleport from this altitude to the next altitude, do I? I pass through all of those inputs. And at every one of those inputs, there is an output. Do you understand? Excellent. I am done. Your job today, and I don't know how it happened, but your job today is page 154. For some strange reason, it's labeled as being 12 to 15, but it's actually 10 and 11. But you're doing this page. Page 154, right? Meow. Okay? Will you have homework? Not if you're quick, because you got 15 minutes left in class. 15, that's what I said, 15. I said 15.